Alright, welcome to section 6.3. In section 6.2 we multiplied and divided rational expressions, and now we are going to add and subtract them. So typically learning how to add and subtract objects comes before multiplication and division, but in rational expressions it tends to be more difficult to add and subtract rational expressions. Just like rational numbers, like fractions, you have to get a common denominator before you can add them, and that's the difficulty. Okay, so basically, obviously, if the denominator is identical, like in both these, if they're equal, then you can just add the numerators. Okay, like in this example right here. Add them together and you get this, then simplify from there. The big question is, what if these are different, right? What if the denominators are different? Then you're going to have to find a new denominator, a common denominator. Okay. And to do that, what you're basically gonna do is you're gonna simplify first. Simplify, or I should say factor actually. What you're gonna do is you're gonna factor first. And then, so you're gonna factor the denominators first. Okay, notice how this 3 was taken out, and what this will do is it will make it easier to find a common denominator, or find the lowest common denominator, okay, what's called the LCD, and that would be the second step. Find the lowest common denominator between them. So if you take a look at this fraction right here, and this fraction right here, 3x minus 4, and then you want to subtract it by 3 over x minus 4. So here, the lowest common denominator would be 3x minus 4. All you have to do is multiply this term right here by 3 over 3, and now you're going to have 3x minus 4 as a common denominator, a denominator for both of them. Then you can add the numerators and simplify. So I'm going to walk you through how to do just that, just the LCD spot first. Okay. So like I said, you're going to factor first, and step 2 here is a bit confusing. This would be an algorithmic approach to how to find this. By inspection, it's quite easy, but what basically you're going to do is you're going to write each factor multiplied by each other, okay, just like down here. If a factor appears once in either or both denominators, you include it only once, okay. But if it appears twice, then you would include it twice, and so on. Okay, so if you look at this example right here, we have x squared minus 9, and then we have x squared minus 6x plus 9. Step 1 is to factor. So you factor, and this is what you get, these 3 terms. So take a look. So what would be the lowest common denominator here? What's the LCM? Right? Sorry, the LCD. And it's pretty easy to tell because we have x minus 3, x plus 3. This time it appears both. Okay, it appears in both. Now if it appears twice, the lowest common denominator will have to have it twice. But we also have this x plus 3 term. So basically, all we need to do is we need to multiply this guy by x minus x plus 3. And we need to multiply this guy by 1 more x minus 3. Then they would be common, and that is the LCD. Okay. If that's confusing, let's work on an example, and hopefully this will make sense to you. Look through the example I did, and I have a walkthrough for you. That's very nice. But now let's do our practice problem here. We're really starting at the basic here because all the denominators are the same. So we won't have to worry about LCDs at the start here. Are equal. That implies you simply will add numerators. So we can go ahead and add the numerators. So for instance, in this one, m minus, so for part A, we could rewrite this right away as the following. Notice how I use brackets here, because this negative is actually distributing to both. Okay. Once we have that, we have m minus 1 over m equals negative 1 over m. It also says to identify any non-permissible values. And right from the start, if n is, and what am I doing here? So sorry. These should be n's. So that's the answer. And clearly, n cannot be 0. For b, we have 10 minus 1 minus 8 minus 2m. This is all over 4m minus 3. Okay, I gotta try to write neatly here. And we have 10m minus 1 minus 8 plus 2 over 4m minus 3. See, that was neat. That's how I should write all the time. Okay, so now we collect like terms. We have 12m minus 9. You can clearly see what's going to happen here. But before I go on, I'm just going to identify the non-permissible value here. M, by the way, cannot equal 3 over 4. Otherwise, this denominator would be 0. I set 4m minus 3 to 0 and solve for m there to get that value. Okay, but now I can go ahead and factor a 4 out. And that will, what am I doing? Factor 4. Factor a 3 out, sorry. Factor a 3 out. It's been a long day. Here we go, factor a 3 out. Then we get m minus 3. And really doesn't get us anywhere. Okay. That appears to be the simplified answer there. And for part C, looks like quite a long question. Basically, we're going to have 2x squared minus x plus 3 minus 6x minus 8 all over this denominator, right? It's the same, so we can just do that. So what we're left with is 2x squared minus 7x minus 5 over x minus 3, x plus 1. Okay, so clearly for this one, x cannot equal 3, x cannot equal negative 1. Okay, maybe we'll in a different color here so that stands out. Those are the non-permissible values. Okay, and now, of course, we should be able to factor this. That will probably give us a nicer result. So if we go 5 and 1, negative, and and for this one, and it doesn't appear to be factorable at this point. Okay. So what we're going to do is we're just going to, so this can't be factored. I mean, it can be if we use the quadratic formula, but it's to solve, sorry, it can't be usefully factored to cancel anything, so we will simply leave it like this. Okay, so let's move to an example where the denominators are different. So you can take a look at the examples I did. Okay, it can get quite lengthy here. So, different denominators now. So what we're going to first figure out is we're going to start off and we're going to factor, and then we're going to find the LCD. Okay, so when we first factor the first one here, so we have 4 over p squared minus 1 plus 3 over p plus 1. So this will be the first result here. So right away, I mean, it's almost like it's almost like saying this is 2x and this is just 2, or this is just x and you have to multiply top and bottom by 2, right? You have to make these the same, these denominators. You have to make them the same. And the easiest way of doing that is leaving this one on the left as it is and just multiplying the tops and bottoms here of the second one by the missing factor, which is the following. Okay? Therefore, when you move on, this will be your result. What we'll have is, and I'm going to show all my work for the first one, we're going to have p minus 1, p plus 1, plus 3, p minus 1, p plus 1, p minus 1, which is the same as the other denominator. From here, what we're left with is basically 4 plus 3p minus 1 over p minus 1, p plus 1. Now, it's good to note that the non-permissible values here are p cannot equal plus or minus 1. Okay? Those are the non-permissible values. Because here we're going to cancel them out, so it's always important to take a look at that beforehand. So we're left with 4 plus 3 over p plus 1, which is 7 over p plus 1. Okay? For part B, which I'll do down here, we have a lot of things we can factor in the denominators for this question. So here we have, let's see, we're going to have 3 and 2. It's going to be a positive 3 and a minus 2. Minus x minus 2 all over, and this will reveal to us what we need as a LCD. Okay. So what we're missing from this side is we're missing x plus 1. Right. From this side, we're missing x minus 2. So the LCD in this case, and I'll do that in a different color, the LCD is going to equal x plus 3 is common to both, x minus 1 minus 2 needs to be common to both, and x plus 1 needs to be common to both. That's what it is, right? Basically, you're going to multiply both sides by this, or we're going to try to make both sides, both denominators this LCD. So what we're going to do is we're going to multiply the left side by x plus 1 and the right side by x minus 2. This will give us x minus 1 in the top, okay, times x minus 1. Because on the bottom here, on this other one, we're going to have x plus 3, x minus 2, x, this should be plus 1, x plus 1, all subtracted by x minus 2, that's this right here, and then we're going to multiply this term by x minus 2, okay, because that's what we're missing. And we have x plus 3, x minus 2, ran out of room here, it's going to be x plus 1, that's not a fraction. Okay, running out of room. For the next one, I'll erase all this. So when you add, what you're left with is x minus 1, x plus 1, minus x minus 2 squared, all over x plus 3, x minus 2, x plus 1. Okay? Now, by the way, your non-permissible values are negative 3, negative 1, and 2 in this case. Okay, I'm looking at the denominator here because now things will cancel. Got to be careful when you cancel things though, because they have to be common across here and here because we're separated by a division or a subtraction sign here. So the only thing that we can do here is to really, let's see, is to possibly just distribute. This is difference of squares. What you're left with is x minus 1. And what you're going to be left with here is x squared minus 4x plus 4. This is all over x plus 3, x minus 2, x plus 1. Now I'm going to have to clear the board here. Okay, let's clear the board. And let's move on. From here, we're going to, this is what we're left with. We're going to distribute this negative sign. And that will cancel out the x squared term. It's quite an involved question here. Deceptively long question. And what we're left with is 4x minus 5 on the top and multiplied by all this denominator. Okay? And I think we can stop there. Okay. We can stop there. Now the final question is C. And actually I think it's a shorter question. So B was the long one. B was quite unsatisfying actually because the denominator didn't cancel at all. Okay. But that can obviously happen. But let's see how we fare with C. So the first strategy for part C, I'm going to rewrite this, actually. I'm going to rewrite as one fraction. And what I mean by that is I'm going to rewrite the numerator and denominator as one fraction. So for part C, what we're going to have is we're going to have 2y minus 4 over y all over y squared minus 4 over y. Now how the heck did I get that? Basically, this is 2 over 1, this is y over 1. So you're just getting a common denominator. So to get a common denominator here, you want to go to the LCD is y, so you're multiplying both top and bottom by y here to give you 2y over y minus 4 over y, i.e. 2y minus 4 over y. Similarly over here, we are doing the same thing, multiplying top and bottom by y to give you y squared over y. Okay, so from there, I'm actually going to rewrite this as 2y minus 4 divided by, so I'm actually doing nothing, I'm just changing the notation. That was nothing at all. Okay, it didn't do anything at all. The adding and subtracting part of this question I already did, okay, right here. The rest of this is division, so going back to 6.2. So this is a particularly good question because it's kind of cross-curricular. It's kind of a cross-section. So here, I'm going to multiply by the reciprocal, and now we're back to multiplication and division, which is great because, you know, it's a much easier procedure, I think, multiplication and division. Here the y's cancel, by the way, and we're left with 2y minus 4 over y squared minus 4, which I'll just factor the difference of squares. You can now factor the numerator, and you're left with the following. Now I'm not going to actually right away, I'm just going to first of all say y cannot be plus or minus 2. Okay, what else can y not be? Well, y can actually, there's many things y can't be here. Y can't be 0. Okay, looking back from the start. Can't be 0. And that appears to be it. Okay, so that's something you got to keep in mind. Y can't be 0. I'm really looking at this guy right here, y squared minus 4y, and if you set that to be 0, okay, that's where a lot of problems can occur. Okay, so from here, y minus 2 cancels, and therefore 2 over y plus 2. That is your solution. Okay, and here are your non-permissible values. Okay, so that's basically it. So it's pretty straight up procedure. Just find the LCD and go from there. So work on the practice problems and then head on to section 6.4.